Hi everyone. So make sure you try these problems first before you jump in and just watch me do them, because it's more important if you try them first. All right, so our first one here, we have triangle ABC is graphed on the set of axes below. The vertices of triangle ABC have these coordinates, and they are asking us to find the area. So if you remember, the easiest way to do this, since I can't find the height and a base easily, is to enclose this triangle in a rectangle. And now I can figure out the area of the rectangle. So this is an 8 by 6 rectangle. And now I'm just going to take away all the areas of the triangles. So for example, this triangle right here, this is 5 by 2. So 1/2 base times height. So this triangle right here has an area of 5. This bottom triangle here is 1 by 8. So 1/2 8 times 1, that has an area of 4. And then the big triangle here is 6 by 6. So 1/2 6 times 6 gives me an area of 18. So I'm just going to take away those 3 areas from the rectangle, and I get 48 minus 27, or 21. So definitely the easiest way to do it. All right, let's hop over to 14. So we've got the ratio of the similarity of a square ABCD to square WXYZ is 2 to 5. If AB equals x plus 3 and WX is 3x plus 5, then find the perimeter of ABCD. Okay, so remember, when you're talking, let's draw a square. When you're talking about the similarity ratio, the ratio of the side lengths in this situation is 2 to 5, and so is the perimeter. The area is the one that's squared. So if they're talking about the area, the ratio of the areas, it would be 4 to 25, because you'd have to square them. But this is just talking about the perimeter and the side length, so it's going to stay 2 to 5. So the easiest thing to do would be to say, okay, well, if that's the ratio, that means that I can multiply this side length right here by 5/2. In other words, I'm just simplifying this. I'm making this 1 to 2.5. So either by 5/2 or 2.5, I'm going to multiply this side by this, and that's going to give me this side. So this side length, AB, remember it's a square, so all the sides are the same. So this is side length AB. I'm going to multiply it by 2.5, or 5/2, and that's going to equal the other side length. And now I'm able to actually solve for x. So I'm going to distribute here, and I get 2.5x plus 7.5 equals 3x plus 5. I'm going to subtract the 2.5x. And I get 7.5 equals 0.5x plus 5. Subtract the 5. So 2.5 equals 0.5x. Divide by 0.5. And that gives me x is 5. So x is 5, but that's not the answer. They want to know the perimeter of ABCD. So I'm going to put in x is 5, and that gives me 8. Still not the answer, though. They want the perimeter. So all 4 sides are 8. So 8 times 4 is 32. All right, next we got 16. The square pyramid drawn below has a volume of 175. If the height of the pyramid is 21, what is the perimeter of the base? All right, so on your reference sheet, you can look up that the volume of a pyramid is 1/3 base area times height. And I know it's 175. I'm also told it's a square pyramid, which means that this base here is square. So all of these sides are the same. And our height is 21. So I'm going to do 1/3 times 21 is 7. And then I'm going to divide by the 7. And 175 divided by 7 is 25. So that's the base area. This base area is 25. Well, area is x times x, or x squared. So when I take the square root, that means each side is 5. And now they want the perimeter. So I'm just going to add up all 4 sides, and that's how I get 20. 17. A fish tank is designed to be placed on a stand in the corner of a room with perpendicular walls. So when I first looked at this problem, I was a little confused, but this right here is the stand. So then up top here, this is your fish tank. The tank can be modeled using part of a cylinder, as shown below. The inner length of the fish tank along the wall is 22 inches, and the height of the tank is 27 inches. How much water to the nearest gallon does the fish tank hold? And they give me a conversion. So I'm filling this fish tank, which means I have to do base area times height for the cylinder, but I don't have the entire cylinder. In fact, because of the way the wall is, I only have a quarter of it. So the base area is the circle, pi r squared, and our height is h. So I have 1/4 pi. I've got the 22 for the radius of the circle, and the height is 27. So when I plug all that into my calculator, I get 231 inches. Oh, nope, sorry, that's my conversion. Oh, I didn't write down what I got. All right, let's do it then. So let's see, so I've got 1/4 times pi times 22 squared times 27. So I've got that number. And this is it, everything was in inches, so this is inches cubed. But now I'm told that I want to change it to gallons. So I've got to take this number and I have to change it to gallons. So this is in inches cubed. In 1 gallon, there's 231 inches cubed. So you either know you're supposed to divide just because it makes sense to you, or if you set up the unit analysis we've done, you can see the inches divide out when I put them diagonally. So I'm left with gallons. So I'm going to take this number, keep it in my calculator, and just divide by 231. And it wants me to round to the nearest whole number. So that would be the 44 gallons. $33. So 33, we're done with multiple choice for a moment. And 33 is a part 3. So this is a little longer of a problem. It says a garden bed pictured below is a square prism with a rectangular prism taken out. The inside length of the square prism is 6 feet. So this is 6 by 6. It's a square prism. The rectangular prism taken out has a width of 2 and a length of 4. The diagram below shows the top view of a garden bed with its inside measurements. The garden bed is filled with topsoil to a uniform height of 1.25. So this is 3D, and they're telling us that this height right here is the 1.25. Determine and state the volume of the topsoil in cubic feet. Well, the first thing I have to do is just figure out the area. And once I know the area, I can multiply by how high it is. So it's that generic formula of base area times height to find this volume. All right, well, let's see here. I've got this square, so 6 times 6, but now I have to remove the rectangle, and the rectangle is 2 by 4. So I've got 36 minus 8 is 28 feet squared, and now I'm going to multiply that by the 1.25. So 28 feet squared times 1.25 feet gives me 35 cubic feet. Each bag of topsoil sells for $3.68 and contains 2 cubic feet of topsoil. State and determine the total cost of the bags of topsoil that must be purchased to fill the garden. So I've got the 35 cubic feet, and there's only 2 cubic feet in each bag. So I'm going to have to divide to figure out how many bags. It comes to 17.5 bags. So that means I'm going to have to round up to 18 bags. So 18 bags times $3.68. So 18 times $3.68 gives me $66.24. If you have any further questions, we can always talk when I see you next. So now what you're going to do is you are going to work on January of 2024. So that's on page 24 of this big packet. You're going to leave the rest of January of 2025 for us to work on in class. All right, have a great day, everyone. Bye.